intercept. So where it hits the y-axis, percent. And double check when you plug in 0, anything times 0 is 0, plus 3 gives you y equals 3. So I automatically get that point right there. From there, I can use the slope, -4/3, rise over run. So a rise of -4 means drop -4. So 1, 2, 3, 4, and then run, that would be right 3. 1, 2, 3. So there should be a point right there too. Double check that. If I plug in 3, multiplying fractions, I'd look at that as 3 over 1. And when we multiply fractions, we can cancel ahead of time. So that's -4 plus 3. So y is definitely -1 there. So for sure, I have the point 0, 3, and now I have the point 3, -1. If we wanted to get another point to double check, we could do something like plug in 1 and see if that lies in the middle there. So if x equals 1, I'll get y is -4/3 times 1, which is -4/3 plus 3. Common denominator would be 3. So I have to multiply top and bottom of this one by 3. So now that gives me -4 plus 9. Common denominator is 3. So what's that? 5/3? And 3 goes into 5 once with 2 left over. So it looks like this is going to give me the point 1, 1 and 2/3. So if I graph that, be right about there, which is in line with the other points. So it looks like I got the right sequence there. So the line looks something like that. So using the slope is nice because you'll often end up at whole number points, whereas if you just pick some x values, they sometimes come out fractional, and most people like to avoid fractions, fortunately. All right, are there any other ones?
Is there going to be like on the homework a while ago, it was like f and then parentheses x or something like that?
Oh, that function notation? No, I don't put that on.
We had the 2.8 prep last night before I was going to do the whole thing.
Yep.
And I have a question on B, C, and then.
Okay. So 2.8 prep. Number 2?
Yeah.
Sorry. Okay, so let me just highlight those. Just a minute. Weird. Just clean that up a little. And take it all. Strange. All right. Just clean this up a little. So there's one set of statements. Here's the other ones. All right, so we're comparing 1990 rent and income, 2010 rent and income. All right, so what are the questions we have to answer? How can both pairs of statements be true? So you had trouble with B and C, you're okay on that one? All right. So calculate Jeff's income in 1990, calculate Jeff's income in 2010. All right, so based on these statements, the $600 per month is 20% of his income. So math-wise, of means multiply. So if I knew his income, I would multiply it by 20%, which as a decimal would be 0.2 or 0.20, and that would give me the 600. So that's in 1990. So to solve this for the income, I would divide both sides by 0.2. So then the 0.2 divides out, and that tells me the income has to be whatever 600 divided by 0.2 is. So we whip out our calculator. 1,200, is that right? No. 3,000? I think that's 3,000. What is it? It's 3,000, yeah. All right. So one way to do that without the calculator, I could shift that decimal over and move that one over 1, 2. That gives me 6,000 over 2. And so half of 6,000 would be 3,000. All right, so that's 1990. 2010 would be pretty similar. So in 2010, we would have the income times 10% equals 1,200. So we would divide both sides by the 10%. That gives us the income. And so that should be 12,000 on that one there. Other questions on homework or preps? 2, 8, 7, and 8. Okay. Okay, what percent of national receipts, so national receipts is just another phrase for tax revenue, was the national debt in 2010? So then we have to look down at the chart for national receipts, which is this one right here. So in 2010, according to this graph, let me copy that. I trace that over here. Just from color, I want red maybe. So it's somewhere above 600%. So I'm going to guess that it's 620% of tax revenue. So that is our debts. In 2010. So that's number 7. And number 8, is it true or false that national debt has never been higher and is way out of hand? Because there's a statement up here that says the 2010 national debt is way out of hand and has never been higher. 2010 debt, according to the first chart, was about 13.5 trillion. Seems pretty high. When we compare it to the GDP, gross domestic product, or tax revenue, is it still way higher than other years? So here, 2010, if we compare the national debt to gross domestic product, it's higher than 2000, 1990, 1980. It's not a lot higher percent-wise, okay? And sometimes percents are more meaningful than the actual amount of change, because that compares to how much the country was worth as a whole at the time, okay? So generally, if somebody's worth more, they borrow more, right? Also over here, if we compare it to taxes, not too bad. If we go all the way back to 1950 didn't have a lot of debt, but if you compare it to what the country was worth or getting an income, 2010 is not as bad as it was in 1950. So I think you could argue either way here. Yeah, 13.5 trillion is pretty out of control. It's a lot of money. But compared to national debt, it's not too much worse than it was in 2000. And compared to taxes, it's not too much worse than it was in 2000. But it's still a lot. So you have to decide how you want to respond. There's multiple ways to respond that are accurate. Other questions? All right. So has anyone had a chance to look at the practice final? So there's a couple of versions. There is the online one, which you have to do for sure before Monday morning. And there's the printable version. And the printable version, the last page. So this is different than you printing it. This was me printing a copy of it, and I cleaned it up a little bit. Somewhere, the last page has answers. Some of the questions will be a little different because I changed the numbers a little, but others are exactly the same. So that can help if you want to look at that. So let's see, what are the kinds of problems that have been challenging?
Can I ask a question? I never exactly got like the 2.4. Like where you got population density or like being
2.4 was population density.
2.5.
Yeah, okay, we can.
Like with the
I have-
and stuff.
I have some here about density, so let's see. There, that's percentages. There. It's almost density. Income tax. There we go. Chickens. That's number 14. All right. Practice final. Number 14. Let's take a look at this one together. That's not the right one. Oh, I changed the order. I forgot. Where did I put the chicken problem? There it is. Okay, number 18. Move it up a little. So chickens that are not caged for 24 hours are sometimes called free-range chickens in the US. And let's see, as long as they spend some of their time outside. In the European Union, they have some additional restrictions, one of which is when the chickens are outside, the density has to be, let's see, no more than a quarter of a chicken per square meter.
Yeah.
Okay, so what does that look like? A quarter of a chicken per square meter. So, oops, that's what I want. So chicken density. So we've got 0.25 chickens per meter squared, square meter. So the next question is, how many square meters is that per chicken? So basically they want us to flip this ratio. So I'm going to rewrite it as 1 square meter per 0.25 chickens. And so I want to turn that into a unit fraction. So I have to take 1 and divide by 0.25. A couple ways to do it. You could realize 0.25 is 1/4. And if you flip 1/4, you get 4/1. So that should be 4 square meters per 1 chicken. Would be one way to look at it. So that's what I get on that one. Other things we could do is we could check out how many square feet is that per chicken. So let's do that, because that's kind of similar to the question you were asking about, Emily. So starting with 0.25 chickens per 1 square meter, I want to change that into chickens per square foot.
Square foot or square mile?
I want to do square foot. Oh, we could do like they do with regular populations, change it into square miles. That would be an interesting calculation. Let's stick with square feet here. So we need a conversion factor for square feet to square meters. So let's look something up. So meters to feet. So here it says that 1 meter is about 3, let's call it 3.3 feet. So 1 meter equals 3.3 feet. How do I change square meters to square feet then? Anybody remember? Yeah, we got to multiply each by itself. So 1 meter times 1 meter is 1 square meter. And then 3.3 times 3.3 will give me feet squared. Square feet. So 3.3 squared is, not cubed, squared, 10.89. So 1 square meter is equal to about 10 points, was it 9.8 or 8.9? 8.9. 8.9 feet squared. So converting here, 0.25 chickens per 1 square meter. We're going to get rid of square meters and convert to square feet. So this says I'm going to have to divide by 10.89. So whip out a calculator, do that division. That'll get us rid of square meters. So 0.25 divided by 10.89 gives us 0. We'll go to just 2 decimal places. So 0.0, I would just go 0.02, it's close enough. So that's about 0.02 chickens per foot squared, per square foot. So those kinds of numbers always look bizarre, so we're going to flip that on its head and see how many square feet each chicken has. So if we have 0.02 chickens per square foot, we're going to rewrite that as square feet per chicken. So what's 1 divided by 0.02? 50. So that means there's 50 square feet for each chicken when we flip it. So requirements are a little stiffer. That's a lot of room for a chicken. So in the EU, they can't be free range unless they have that much space.
Those are pretty happy chickens.
Those are some pretty damn happy chickens. Yeah, it's a lot of running around room. So here, so let's see, this one right here we figured out was 4. So a farm in the United States wants to meet the EU guidelines. She measures her area in her yard, rounds to the nearest square yard. How many yards does she need for 1,100 chickens? And so here they give us a conversion factor. What's that?
How much?
What are you going to do with 1,100 chickens? Sell them for meat, eggs. A lot of chickens. Big farm. All right, so we need to use this fact here. So 1 meter is 1.0936 yards. So new page. 1 meter is 1.0936 6.3 or 3.6. I'm in trouble with digits today. 3.6. yards. So I need to change that into square. So I have to take the 1.0936 and multiply it by itself. 1.0936 to get square yards. Raise to the second power. So they're using 4 decimal places, so I'll use 4 decimal places. So that'd be 1.1960 when we round that. 60. So we're getting 1 square meter, or meter squared, is equal to 1.196. Is that what it was? 196. Yeah, because when you round that 9 up, that's going to bump that 5 to a 6. So 1. I can't keep that straight today. 196. There we go. 1.196 square yards. All right, so we have a density of 0.25, let's see, chickens per 1 square meter. And we want to convert that to, actually we should go with the other one. Doesn't really matter, I guess. We have 4 chickens per, no, I'm getting that wrong. What was it again? 4 square meters, that's what it was, per 1 chicken. There we go. And so we want to rewrite that in terms of square yards. So we get rid of square meters here, change to square yards. 1 goes down here, 1.196 goes up there. So that will get rid of square meters and give us square yards per chicken. So calculator, what's 4 times 1.196? .784, and so that's square yards per 1 chicken. So now we need to scale that up to more chickens. How many chickens do we want? Yeah, so we just need to multiply this by 1,100 chickens. And that'll just give us the square yards that she needs. Mm-hmm. 1,262. 5,000. That's what's more like 5,262 square yards. Is how many yards she's going to need for all those chickens. There's that test here, and that happens to be one of the options there. Submit. All right. Were there other kinds of problems y'all wanted to go over?
Are we gonna have a conversion sheet? So like number 1?
Yeah, so I mentioned earlier, for the final, you can have all of your worksheets. Which reminds me, I have a couple to give back now. Yeah, so sometimes I just give you the conversion factors. Like with number 1, I didn't give that one. Yeah, I think that was on that cheat sheet on activity, which one was that? Lesson 1.4 maybe? So you'll have that. Let's see, which one was it? Dimensional analysis, lesson 1.5.
How many questions are going to be on this final?
I'm gonna try and get it down to.
Because last time we did 10 or something, it took an hour and a half.
Took the whole time, yeah. Good point.
They're like a whole bunch of different.
I'm going to get it down pretty short. 10 to 15.
Could you go a little more of like what we just did? I don't get this.
Uh-huh. Yeah, so you've got all these conversion factors here that talk about, let's see, there's weight, grams and kilograms, grams and milligrams. And so if you need something that's not on here, I'll have it on the sheet for you. But otherwise, you have your worksheet split back out. All right, so something else along those lines. Let's see, there's the print version. Okay, so that. There's one where I'm going to give you some cities and you're going to calculate the densities. Those are pretty straightforward.
I got that. But I got 2.5.
Yeah. Let's take a look at that. Ooh, I know a good one. That's, oh yeah, that one right there. Let me find that one here. Same place. That one. Here we go. So here you'll each get a question. The cities will differ each time a little bit, but it'll be a comparison of two cities in terms of their density. And then we want to make a statement about how much more dense one city is than another. So let me copy this into the worksheet and give it a try together. So this is similar. Make that font any bigger. Okay. All right, so let's see. According to the 2002 census, we've got in Hermiston, there were 16,745 people on 7.1 square miles. Gave that. And then in Pendleton, we've got 16,612 people on 10.52 square miles. Well, so what I'd like you to do is find the population density of each of these cities. So whip out a calculator, calculate the population densities. What do we get? We can go to the nearest person. So I got Hermiston is about 2,144 people per square mile. Yeah, about 1,579. 1,579 people per square mile. So the next thing I want you to do is we want to do a compare these two and say how much bigger or smaller is one city's population density compared to the other city's population density. So you choose how you want to do it. So try something. So the question is, I want you to write a statement comparing the densities of Hermiston and Pendleton. Okay? And we want to talk about relative change, percent change. Okay? In terms of percent change, how much more dense is one city than the other, or how much less dense is one city than the other. So do a calculation, write a sentence, and then I'm going to put up a couple of sentences and we'll talk about it. Oops. We'll talk about it in just a sec. Going to write a whole bunch of sentences based on my calculations, and you guys are going to help me figure out which ones are right and which ones are wrong. Let's do 5. Okay, so I got 5 statements here. Some of them are true and some of them are false. How about number 1? Did anyone have something like that one? Kristen? No? Elizabeth? You did? How did you come up with the 1.36? Okay, so you took the Hermiston population and divided by Pendleton. So that would be 2,144 divided by 1,000, was it 579? And that comes up to be about 1.36. Yeah. So whenever you compare two things, in a straight division, then basically you're coming up with you're coming up with a multiple. If you think about this algebraically for a minute, to get rid of a denominator, we multiply the denominator to the other side. So I could rewrite this by saying 2144 is about equal to 1.36 times 1579. So I'm literally saying multiply this by the bottom number to get the top number, because we got to increase that by a little bit. Now the 1 here represents whatever the denominator was. The denominator is the original number we're comparing to, and it is 100% of what we're starting with. So then the 36 part represents the percent increase, because it's over 100%. So if I consider there's a 36% increase in the density from Pendleton to Hermiston, then if I go back here, which statement says that there's a 36% increase in Hermiston compared to Pendleton? Second statement or the third statement? The second statement, yeah. So the first statement is correct. The second statement is also correct. There are two different ways of looking at that 1.36. Okay, next question. Is Pendleton 36% less than Hermiston? Okay, it turns out no, it's not true when you do it that way. To talk about Pendleton being less than Hermiston, Hermiston then becomes the denominator. So if I flip the fraction and instead I look at Pendleton versus Hermiston, did anyone do that division? Yeah. Okay. So when I did that one, I came out with 0.74 roughly, 0.74. Two ways to think about this one. If I bring Hermiston to the other side, that means literally Pendleton is equal to 74% of Hermiston. And that was that statement I wrote right here, number 4. Pendleton is about 74% as dense as Hermiston. So take Hermiston's density, multiply it by 0.74, that's going to give us Pendleton's density. Okay. No. Hermiston is 36% more dense. Pendleton is 74% as dense. If I want to talk about less, then I have to look at the change. Okay, so my claim is that, which one is wrong? Number 3 is wrong, but 4 and 5 are correct. Okay, so let's take a look at why. So 4 is correct just because of this calculation right there. You take Pendleton divided by Hermiston, you get 0.74. Algebraically, you can move the Hermiston up as a multiple of the other side. So literally, Pendleton is 74% of Hermiston. Right? That's a straight English translation of that math right there. All right. So Hermiston is our base value, right? In this case, your base value, right? That's what we call the original amount. That's always 100%. Now, would you agree Pendleton is less than Hermiston? So if I take 100% and I subtract 74%, what do I get? Almost 26%. And that's where I came up with the 26%. Another way to come up with that, take the 202,044, subtract the Pendleton density, 1579. Somebody help me out with a calculator. 565. If you take that 565 and you divide by, let's see, what are we dividing by? Hermiston, 2144, what do you get? 26%. Yeah, that's the 26%. So Pendleton is 26% less dense than Hermiston. So to talk about more or less, you have to compare it to 100%. Or you have to look at the absolute change divided by your base amount.
Did you use the 565 instead of like putting 26% like I did?
You could just, yeah, so that it wouldn't be wrong to say the population of, the density of Pendleton is 565 people per square mile less than Hermiston. But I was looking for a relative change here. And so that's an absolute change, not a relative change. So it's a correct statement. It just wasn't what I was looking for. But that is correct too. Yeah, so these are tricky. It takes time to get used to. Every time I hear something like this in the news, I got to really stop and think about it. And every time I calculate one, I got to double check with myself. Did I calculate it right? Am I using it in the right direction? Because it's not something we do every day. However, these things are in the news every damn day. They're always talking about percent change here, percent change there, this increase, that increase. Sometimes they talk about absolute numbers. Sometimes they talk about percent. And I always ask myself, why? What was their point of view? How are they trying to bias me? Okay. Do you think the news ever talks about percentages without consciously thinking about whether that's going to affect the way somebody thinks? They always think about how they're affecting the way you view something. Always. If they're not good news people. Okay. And every time they talk about percentages, they're general percentages or change. They're generally leading you in the direction they want you to go. And so always got to stop and question that. All right, we got time for one more.
I get frustrated with news because so much of it is not factual. It's just like opinion.
It's a lot of opinion. Yeah.
Yeah. Woman, half an hour,
And-
whatever, she's like,
And the other problem with the news isn't necessarily the news, it's us. Because we believe what we want to believe. It doesn't matter whether somebody gives us facts or not. If it doesn't fit with what I want to believe, I'm just going to choose to ignore it. It's a problem I have every day.
Go back to bed.
Taxes, oh good, I was hoping somebody would mention taxes. Yeah, let's do, how about the one with the tax table here? Okay, all right, so I'm gonna go see if I can find it in here. Where did I put it? Stack of money, that one's not too bad. That one's actually pretty easy. All right, so I got the tax table here. So just looking at this tax table, let me copy that so it's more readable. Screen, blow it up. All right, so based on this tax table, the first question is, so assuming people make more than 8,500, what amount or what tax does everybody pay on the first 8,500? So for the first 8,500 anybody makes, they have to pay 10%, okay, or $850. And the first question here asked about what rate? Yeah, so everybody pays 10%. All right, next, suppose somebody earns 25,000. What tax are they going to pay? So taxable income is 25,000. They are in the first row, second row, or third row, or further. Yeah, they're in the second row here. So it says they're going to pay. So as far as tax, they're going to pay $850 plus 15% of the excess, because they've already paid for the 8,500. So anything over that. So then I have to take my 2,500 or 1,000 and subtract the 8,500 I've already paid on. Okay, so whipping out my calculator. I've got 25,123 minus 8,500. So that means I have another 16,500 to pay tax on. So 16,500, and on that I pay, was it 15%? So 0.15. So that means I need to pay an additional $2,475 in taxes. So this part right here is another 2,475. And so I have to add that back to the 850 to get what I pay. So what's that going to give me? A total of 5, 2, carry the 1, 3, carry the 1, $3,325 it looks like. And stop working. Oh, there it goes. Next question, and then we'll quit. Asked about if someone earned 63,500. So we'll put that in blue, 63,500. That would put them in the third row here. So it's going to be pretty similar. The amount of tax that they pay is going to start with, they have to pay 4,750 plus 25%, so 0.25 of the difference over the 34,000. So you're going to have to take the 63.5 and subtract the 34.5 and see what's left to pay. The last question says, given the amount of tax they pay, what's the actual percent that they pay? So to figure that part out for part D, we're just going to calculate that tax, whatever it is, and then divide it by how much they made, 63,500. And that will give us the actual percent. And we are out of time for fun with math today. If anyone wants to do math tomorrow, I will be around. Stop by or give me a call or send me an email. Otherwise, we have an exam bright and early. If you have stuff to give me, you have to give it to me by Monday morning. If I have any of your worksheets, I will get them back. Let's see. Stop by tomorrow if you want them for the weekend. I've got a couple more to go through here. Here, only 2, 8. Okay.
So we'll be here at 10 to 12?
Yep.
Okay.
Okay.
See you then.
Okay, sounds good.
Oh, we're here today.
Today, let's see. I've got to run some errands from like 2 to 3-ish. And then I'll be back in this building from like 3 to 5. And then I'll be in the science building computer lab from 5 to 8. I'll be here all day, pretty much.
If you're not, you haven't dropped off anything.
Yeah, to the, my
It's on the
office.
wall, right?
Yeah, it's way down to the right, it's on the wall there.
Perfect.
Just drop it, yeah. And then if you want it back tomorrow, I can just let me know.
Tomorrow I actually have a dentist appointment,
Okay.
so we're not able to come up
Yeah,
here.
be on campus.
Yeah.
All right.
Chances are they're gonna either pull 2 teeth or tell me to come back so they pull 2 teeth.
Yeah, I think I gotta get a tooth pulled. I'm kind of bummed. I've been avoiding going to the dentist.
They refused to pull. I'd lost enough teeth on the bottom to make the wisdom teeth move forward,
Oh.
but not on the top. But my dentist refused to pull them, or they both shattered.
All right, good luck with that, man.
But
Yeah, so,
Monday at 8.
Monday at 8 is our exam. That's the official time. If you can't make that for some reason. let me
So I
know.
can make it. It's just early.
Yeah. It is. And then if you want, I can, after I grade your stuff, I can scan it and send it back to you so you can study.
Well, we can use it on.
I'll give it back to you for the test, yeah. So at the very least, I'll give it to you when you come to take your test. That's fine. Okay.
It'll still be pretty fresh.
Yeah.
Math isn't something I easily.
Yeah, you seem to do that. All right, sounds good. Good luck.